Sometimes the noise of news reporting can numb the significance of a story. For example, the ongoing talks with North Korea over its nuclear arsenal. The fury and force of a nuclear bomb, something we all hope we'll never experience, truly has to be seen to be believed. Which brings us to this report from David Martin.
-10. Miles back, observers from all services and several allied nations stand by for the first daylight tower shot.
The terrible, swift power of nuclear weapons has to be seen to be believed.
This is a really big fireball. It'll be about 2 miles across.
Now, thanks to a project headed by Greg Spriggs at Lawrence Livermore National Laboratory in California, the public can see them as never before.
It's unclassified. It's not a threat to national security.
Starting in 1945, the U.S. conducted 210 nuclear tests above ground, all of them recorded on film from as many angles as possible.
I now declare that the United States does not propose to conduct nuclear tests in the atmosphere so long as other states do not do so.
That ended in 1963 when, for the good of the planet, the U.S. and the Soviet Union agreed to stop testing in the atmosphere.
Let's play this in fast motion, and you can see that Mach stem crawling up.
Unlike most of us, Spriggs understands the physics that produces these spectacular images.
Temperatures can reach anywhere from about 10 million degrees up to about 15 million degrees initially. Degrees Kelvin, very hot, very hot.
At the outer edge of the fireball is a shock wave. What the fireball doesn't vaporize, the shock wave crushes. See those tiny objects in the foreground? Those are tanks about to be hit by the shock wave.
When it first starts off, it's moving at Mach 100 times the speed of sound.
And then there is the mushroom-shaped cloud, which climbs into the sky, spewing radiation.
That's directly tied to the nuclear fallout, which was very, very sensitive to the cloud height.
Using a computer to measure the cloud from one blast, Spriggs discovered the original calculations made 50 years ago were off by a full mile.
Instead of 35,000 feet, it was something like 40,000 feet, and it was because of the way they measured it.
That made him wonder if calculations from all the other blasts were wrong as well. It was more than just academic curiosity. Those calculations are used to predict the performance, what Spriggs calls the yield, of today's weapons.
If you measure the shockwave radius and you're off by 1%, you will be off by 5% in the yield.
So Spriggs set out to reanalyze and then release to the public the estimated 9,000 rolls of film that had been shot. He found most of them in the archives at Los Alamos National Laboratory in New Mexico, birthplace of the atom bomb. Untouched for decades, a vast scientific treasure trove left to decay.
I've had a challenge with some cans, just getting the can open.
Jim Moy is one of this country's foremost film preservationists. Once entrusted with the Zapruder film of President Kennedy's assassination, he now has the job of retrieving the only visual record of America's most fearsome weapons.
I want to first, once I open a can, determine the condition of the film. And one way is by smell, because any acetate-based film, as the base that carries the image starts to decay, it will put off an odor, which is called vinegar syndrome.
Smells like vinegar.
It does, exactly.
It sounds like basically it's a race against time.
It really is, because until those cans are opened, you don't know the condition.
Some of the film has been lost forever, but Moy was able to restore most of it, using a scanner to convert each frame to a digital file.
Here, we're able to analyze all the fireball films in an automated way.
Digital technology allowed Spriggs to analyze the films with much greater precision.
Those are high-energy X-rays running down the cable and vaporizing the cable.
And he found that the measurements made decades ago over the Pacific Ocean and Nevada desert were inaccurate.
The best they could do in the 50s was on the order about plus or minus 7, maybe 10%. So we're talking maybe plus or minus 100 kilotons for a 1 megaton shot.
A kiloton is an explosion equivalent to 1,000 tons of TNT. 100 kilotons is about 6 times bigger than the bomb which leveled Hiroshima, killing a third of the population. The Pentagon would not tell us if the new data from the old tests had forced any change in current nuclear targeting plans. But that does not change the impact of simply looking at images like this. frozen for 1/1,000,000th of a second from 2 miles away. This fireball truly looks like an alien come to devour the Earth.
What do you hope the public gets out of watching
I hope they
these?
appreciate just how horrific these weapons are. This is something that can kill millions of people in the blink of an eye.
Spriggs is one of the few nuclear weapons designers old enough to have actually witnessed a nuclear explosion.
The 1962 weapon effects testing, Operation Fishbowl.
A high-altitude nighttime blast over the Pacific.
The sky lit up like it was noon. No matter what direction you were looking, it just lit up. And it took about 15 minutes for all the colors to fade away.
How does the real thing then compare with the film?
It's amazing the difference between what occurred out there and what's on the film.
As majestic and fearsome as those photos appear, they don't come close.
Not even close to what you see in real life.